Alrighty, in this lesson we are going to continue our work on function analysis, but this time we're going to use the second derivative and see what that can tell us about a particular function. What we have here is a problem about an epidemic, and the nice thing about living in the times we live in, right, is we're all pretty familiar with how these types of things might go. So here we have this function f of t that models the number of infected people t days after the outbreak, right? The thing I notice about f right away is that it's a pretty ugly looking function. So we could take our derivative of this by hand, but what we're going to do is what we often do with ugly functions is we are going to use our calculator to fill out this table here in a second so we can analyze it. Before we do that, however, there's one thing I notice about this function right away, and I'm going to make a note of it because it might be important later, right? So the thing that I notice is that f is increasing for all t values that we can see. So I'm going to say that's definitely when t is less than or is bigger than 0 and when t is less than 22-ish, right? What that means in our language of the derivative, right, is that f prime of t should always be positive. So it's good to note that here because we're about to fill out some values of f prime of t, and that's a good way to check our work. Now, what I want to do now is describe how it's increasing. So here we're introducing a second derivative. The second derivative can tell us how the graph is increasing or decreasing, right? So the first derivative tells us whether it's increasing or decreasing. The second derivative tells us a little bit more. And what I notice here is at about x equals 12, or t equals 12 rather, the graph starts increasing more slowly, right? So as we see, one person gets infected and it starts to spread quite quickly, right? Until this point at which it starts to level off. So that's the property of this graph that we're interested in here today. So f is increasing for all t, but for t less than 12, f is increasing quickly. And in fact, it's increasing faster and faster the bigger t gets. So I'm going to say it's increasing at an increasing rate. And leave yourself a little bit of space because we're going to elaborate on this later. For t bigger than 12, f is increasing at a decreasing rate. So in other words, in this region, growth is slowing down. So most people have already gotten sick, right? And it's spreading more slowly. Overall, the number of people who are sick is still going up, but not as quickly as it was before. Okay, so that's what we're interested in studying. And what we are asked for here is to fill out a table with values of f prime of t, the derivative, and we know those should always be positive, and with f double prime of t, so the second derivative of f. The way I'm going to fill out this table is I'm going to use my calculator to figure out these values of the derivative, because this is a pretty ugly function. So I've already typed it into y1. I'm going to then type in my derivative operator here into y2. I'm going to type in x here. And then we've used this trick before. I'm going to type y1 here. And then this time for my grapher, I'm going to use x equals x, right? That would be my derivative of whatever I put in for y1 at all values of x, right? So that would be my first derivative. I want also my second derivative. So I'm going to be like math 8 x. And now if I want my second derivative of y1, well, y2 was our first derivative, so I want the derivative of y2. And again, x is my x value here that I typed in. This would be super smart to do this along with me on your calculator so you get a little bit of practice finding these buttons. Make sure your screen looks exactly like mine before you move on. And if I want a table, what I can do is I can hit second and then table. And this gives me a list of values. So notice it gives me all these values of y1, which was f, y2, which was f prime, and if I click over, it does y3 for me as well. So what I'm going to do is I'm going to use those values to fill out this table for f prime and f double prime of t. You can either get those values off your calculator, or I'm going to fill out the table here in a second, so you can copy them down for me as well. Pay attention to the t's, right, so we're not counting by ones here. Okay. So I filled out my values. This was y2 for my table on my calculator. This was y3 for my table on my calculator. First derivative, second derivative. What I notice, right, is there's a sign change right here between 11 and 12. And that lines up with our graph, right? So increasing at an increasing rate means, in this case, f double prime is positive, so greater than 0. And as that growth starts to slow down, we say f double prime we see is now negative less than 0. Okay, so that corresponds now with the second half of my graph. Hopefully you're noticing my color scheming here. And the first half of my graph was where my second derivative was positive. So as we look at our algebraic example down here, we see we have some vocabulary that is new. Concave up is our first interval in our graph. Concave down is when my second derivative is negative. So that is vocabulary that we will need. And then this point in the middle, we call this point where concavity changes an inflection point. This is all vocabulary we'll need to know. Here, we're going to tackle our problems. This is going to be probably more challenging than the Delta Math examples I'll give you first, but this will be a good example to help you tackle these. So notice we're asked for two things. We have increasing and concave up. I would annotate the question. Increasing means f prime is positive. Concave up means f double prime is positive. So notice now I'm asked to check properties involving both derivatives. So I will need both f prime of x and f double prime of x. At this point in your career, you're excellent at these polynomial derivatives. So first I'm going to do, now that I have my derivatives, my increasing intervals. And that is where f prime is positive. I'm going to start by setting f prime of x equal to 0. That means 0 should equal 4x to the third plus 24x plus 36. And then I solve by factoring. And this ends up being 4 times x plus 3 times x plus 3. So this is kind of an interesting case because we get only 1, 0. And that's x equals negative 3. Then I'm going to set my second derivative equal to 0. Which means I'm going to take 0 equals 12x squared plus 48x 36. Factor out my 12 this time. And then, so my zeros here are x equals negative 3 and x equals negative 1. Right, and of course I'm solving these equations. And once I have my zeros, if I'm asked about two properties, I need two sign charts. And here's the trick to these is I'm going to line them up. So I made one sign chart for f prime, one sign chart for f double prime. And I know x equals negative 3 is a 0 for both. So since they're the same x value, I put them one on top of the other. And then I have, for my second derivative, I had x equals negative 1 was a 0. So now my regions line up. It's going to be easier to eventually answer the question I'm being asked. Now, what I know is when I plug in a negative 4, for example, into f prime, I get negative times a positive. That is a positive value. And when I plug in a negative 2, I get positive, positive, positive. So this one's positive all day. And then, let's check here. When I plug in a negative 4 into my second derivative, and I'm looking here at the factored form, I get negative times a negative is positive times another positive is positive. In the middle now, I get, say I'm plugging in negative 2. That would be 12 times a positive is a positive times a negative 1 would be negative here. And when I plug in, say 0 would be an easy one, I get positive, 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 right? So there's my sign chart. Now, remember what I was asked for is where both my first derivative and my second derivative are positive. So in other words, we want everywhere where my sign chart overlaps. So here satisfies my condition, and not in the middle, but up here it does. So there is this region here where my function is increasing but concave down, right? So we're going to skip that when we write our solution. So my intervals are going to be from negative infinity to -3, and from -1 to infinity. So that was why it was useful to line these sign charts up very nicely, because it allows us to see this region where only one of our conditions is true.